Thank you, Ben. And I would like to thank you to all the mentor and the platform. Uh, and good morning, good afternoon, and good evening, depending on wherever you are located from. Today's session, I'll be talking about the SQL Server technology. The topic is mainly very common, and generally every developer or DPA would face this kind of situation in their professional career, basically. So the topic is whenever there is a SQL Server slowness, you would like to get into the finding of root cause of it and how you would like to resolve it. So the session is planned in this manner. First, we would like to looking at the step how to monitor the SQL Server resource uses by the engine. And second step would be to diagnose where is the problem. And third, we'll be looking at the solution, how to fix the problem. And at the end, I'll also introduce a free tool that can automate entire process that we have discussed during the session. So let us understand what could be the main root cause or reasons behind the slowness. One of the problem could be high CPU usage, where SQL Server box is located. And reason for high CPU usage could be query that may take high amount of resource, like your memory, the SQL CPU, or IO even. So overall, we can figure out that it could be because of complex joins in the queries, or the query is very, very lengthy and uh, resulting in a high set of data, which is not required all the time. And that could be also a problem. So when there is huge number of session or parallel session, if the data set is returning in a high number of IOs, then it could be a problem for an application. It could also be because of poorly optimized query. Sometime, we understand that, that development happens in a very fast manner, and the developer could quickly simply write a queries, and they may not do a load test properly in a because of shortage of time, or could be anything, or pressure from the development by the management. It could be they would write simply query to get the output, but it may not at the back end. They do not validate if there is a proper indexing applied, and if the query is using the data scan or index scan or even the table scan. They never look at the query plan, basically. So there are some situation at the development and development time that happens. And the third could be high user activity. All of a sudden it can happen that many concurrent user has filed a lot of requests through your application or backend. It could happen anything. And uh, we can understand by the looking at the example here that uh, there could be all of a sudden surge in number of volumes, like many users will come to for example, if they are coming to a counter to get a ticket, and there are just 4 counter to process a ticket, and there are thousands of people, it could lead to the queue that you are seeing in the diagram. So and some days there could be very small number, and in compared to that, and with this environment, we can see that statistics is totally outdated here. So statistics is also one factor in a database or the organization where there is a large database size. For example, if the database size is in 10 terabyte plus, it is very important that we maintain the statistics also properly. And there are a lot of several jobs, like Ola has written a open source script that could maintain the index and statistics as well. Let's move on to next slide. There could be also uh, latency, latency related issue when there is a huge number of data set returned by the database to the application, and there is a number of high concurrency. It could also happen that disk may perform badly, and to identify where is the threshold, these are the numbers. Basically, if the disk takes more than 30 to 50 millisecond of time, it is considered as bad disk. We'll look into the details, technical side, in next few slides. Before we jump to the technical side, I would like to introduce myself. My name is Chandan Sahu. I'm from Bangalore, India location. Education, I have done Master of Degree in Computer Application and Microsoft Certified Professional. I have 13 years of experience in SQL Server database development side and a DBA role side as well. I'm very much enthusiastic about SQL Server, and I have also with this motivation, I have also built a monitoring tool that is called SQL Planner. It's totally free for anybody, and this tool also can do a backup of your database, auditing live. So all that can be done, that I have crafted this product, and my contact is this one. So let's move to the next slide. Now, how we can monitor the SQL Server resource usage. The greatest tool that SQL Server has introduced recently after, I think, 2014 to 2008 R2 onwards itself, it's called SQL Server Extended Event. It is a very lightweight advanced monitoring system and can be considered as SQL Server profiler basically. And it got matured very much advanced from 2012 onward version onwards. Now let's look at how we can capture the deadlock, blocking, or expensive queries using extended event. I have a few scripts that can monitor all these events like long queries plus deadlock and blocking session. Now, there are two ways to create extended event. One is GUI based, which you can simply go to the management and expand your extended event folder. And here you would be able to open a new session wizard and say, choose your event name. For example, let's say I would like to capture deadlock event. Now I will say, okay, do not use any template. I want to do everything fresh and search for event called deadlock. So there is already a session called deadlock. Similarly, we can capture the event for blocking. So we can see there is blocked session. Sorry. Sorry. Once we choose this, we need to double click on that and do a next. Now in the next session, we are being asked to choose the column fields, basically the information that you would like to receive. Those important event names are like database name, I'm sorry, and we can choose the username and the query plans and SQL text. These are the main event when we need it basically to analyze it further. And at the end, it asks for where do you want to save it basically. Now we have two location to save it. One is on the buffer, and second can be your permanent file basically on the drive itself. The good choice is to, if you would like to persist the data, choose a drive location basically. To speed things up, I have already scripted it and I'm canceling it. And this will generate a script like this. Uh, and you can see that we have applied a filter that any query, in case of expensive query, you would like to monitor only those query which have taken more than certain amount of CPU second. Here I'm saying if CPU second time is greater than 1 second, only capture then, only capture those queries. And duration is something like, okay, duration is something like your total duration, and this is the CPU time. I have given this filter criteria. And where exactly I'm saving it. This is the path where I'm saving it, and how many files it should generate. Basically, I'm saying it 5 number of files should be generated. Each of those files should be of 100 megabytes in size. We would not want to have a lot of files on a server because it can consume a lot of space unnecessarily. And automatically how it happens is like whenever there is a sixth number of files, it will delete the oldest file automatically. So this event happens by SQL Server by itself automatically. These are the main filter criteria that we should focus on. And uh, when we run this, basically, it will create extended event session. By default, when we create it, it does not start it. We have to manually start it by this command saying server state, this session name, and then start it. Similarly, we are creating a session that can capture deadlock as well as blocking session also. So we have given the event name, and in the action, what are the column list that it should save it in the file is what I have mentioned it here. So to speed things up, I have already created it and it is stored and it is in running mode already. Now let us go to the second step. What it will do is, now I'm creating a environment that will create a slowness on my SQL Server box. Second, it will create a deadlock scenario, and it will also generate a few expensive query. That is the reason why it will say that, okay, it is taking a lot of resource uses of SQL Server and causing the slowness. So it is just a very simple step that creating I'm running a query to create a deadlock environment. So it's just a few records in a table, and I'm updating those one of the record in it and waiting for 10 seconds basically. At the same time, on the second session, I'm updating running update command again on the same rows and trying to acquire the rows that is locked by each other basically. Now I'm in the third step. I'm running a few set of query that will consume lot of CPU time. So what this procedure will do is, there is a sample database in my server. It is called SampleDB, and the size is 5 GB in data. It has the procedure will use joining from 15 table plus number, and each table may have few table have around 4 to 5 GB of data, and all of them will join here. And the output of this procedure will be, one of them will return 100 or 200 or 500 records. And at the end, I'm also running the backup of this procedure, this database basically. So I'll initiate this process. And at the same time, I have also initiated a few query that will, that will retrieve data from same server, but from other database. And it is also doing some backup operation. Now let us take a look at the system resource uses. I can see that, okay, SQL box is active and not much, but approximately 5 to 10%. But this is sufficient for us to get to know the root cause of SQL Server slowness and analyze the load event. Okay, now this is what I have triggered. And now once these query that is causing the load on SQL Server is get finished, we would like to see the data that it has monitored and captured in a extended event file. So where are these located? Basically, let us look at the definition. These are located here basically. And if we look at the file, we can see it in this format. We cannot read it by default by simply opening it. To read this, we have a function in a SQL Server side, which is called, one second, extended event. Okay, we have a function called exe file target read file, where we want to specify the file location. So the way to read is, we say that, okay, this is the path and this should be the file name. And there is one tricky point to note here is called star. Okay, as we understood that we can create 5-number files. That means when we say the star here, okay, any file after this is created uh, in a particular, incremental ID number basically. So this is a ID number and followed by GUID number. So up to here, we see that these names are common, but this is different. Okay. So when we say star, we say that read all the file basically, anything that is starting from here. And let us take a look at the raw data format. We see that, okay, there is a deadlock already detected, and it is in XML format. Now, this XML format, reading wise, it's very difficult to read. Now, we need to process this data. Okay, since this is in XML format, we have to pick those each of these nodes basically. Okay, the meaningful information here is, I want to know basically which query has failed, or which query was the victim here in case of deadlock, and which was the winner. And I want to generate a report based on, under which database number of deadlock has happened, and what was the user, what was the database name, what was the application, when it has when this event has happened, and other information like, wait resources, wait time, etc. So these are the meaningful information. To pick those information, we have to read one by one those nodes basically. And this is the function basically. Okay, I have simply written it in a query format, T-SQL format, and this is how it looks like. For your, if you want to, change data for your reporting purpose, you can simply construct and modify these query, and take a look at the way or present it in a way that you want to basically. So we see that, this XML data is nicely captured in a tabular format now. So the function, once we apply the function, we have to uh, split the node one after another. So this is the way to read the deadlock related reports through extended event file. Now we have another query that if we want to monitor the expensive query basically. Here also, in a case of expensive query, the pattern is same. Okay, we say that this is the file location. This could be, where it is located, and there could be number of files. And we apply the same function name to read it. And we are interested in much of valuable columns like, database name, what is the expensive query, what was the CPU time, duration, IO related activities, row counts, and application name that has initiated it. Okay, once we execute it, I'm just simply taking only top 100 records based on the CPU time. Okay, now we can see the format of this data that is coming through XCL file that is called extended event file also is again in the same format, that is XML format, but we need to split it into tabular format so that it is meaningful to understand. And the way to do is the same way. We have to understand which data is located at what location and put it in a particular column. So we can see that, there are some records here that is that was executed under master database, and some of them were executed under sample database, the query details, and CPU details, row count, etc. The good thing about this extended event is it can tell you at the thread level and parameter level of information exactly. So compared to if you would like to fetch data from DMV and compare it with extended event, the exact information you get through extended event is you exactly get the filter criteria also. Whereas in uh, DMV, you don't get that filter condition. It's in a very general format. And let's say if you have multiple cases in a stored procedure, you wouldn't know which query under specific procedure has taken much time and what was their execution plan. But with this extended event, you can pinpoint to exact particular SQL query and you can get their execution plan also. So we see that this is the plan handle and we can fetch the execution plan as well. So we see complete information here regarding that is related to expensive queries. Now let's look at the other factor that can tell that, what was the CPU uses at that particular moment of time, and disk latency, and the connection per database basically. Okay, now let us understand if we run this particular DMV, we can understand at this particular time we had CPU uses amount is mentioned here and how much it was consumed by other process and what was the idle percentage of CPU time. So this is basically if we read from DMOS ring buffer DMV, we get all this information. Now, at the same time, we have to remember that we are running all this query at specific timestamp itself, okay? Because we would like to know at what time the server was slow, and at that time, we would like to know complete statistics of server, okay? So we have to also look into the disk latency. What was the disk latency report at that particular time? As Microsoft recommend that anything greater than 20 to 50 millisecond, the disk is considered as very bad. So my disk, one of disk is like performing very badly. I can see more than anything 100 is very bad. And what could be the scenario here? We have to understand here. Basically, it's my laptop, so it's not well optimized. There are two disks. Basically, one is SSD and other is normal SATA disk. That is where it is giving me the latency. Any databases located on SATA disk is performing badly here in my case. Now, I should also look at the number of connection that is being established at that particular timestamp. Okay, so we can see that here master database is having highest number of connection, which is comparatively to production environment is very less, but still we can monitor. We can understand how to monitor it basically on in our professional environment. And last is we would like to know, if you have a large database, what is the fragmentation of indexes basically? This is important because if you have a database size more than a few terabytes and you have continuous queries hitting on to same databases and indexes highly fragmented or statistics is not up to date, that means um, that means there is a big problem here. Okay, you should always look into the fragmentation part also. Now, just key factor to look into this is highest number of fragmentation plus what is the index size. Greater size of indexes should always have lesser number of fragmentation. Okay, we are looking at simply the problematic area. We will talk about the solution later, but we can see fragmentation percentage here is okay. This has very high page count, and in my environment, this main table is having very high fragmentation, more than 50%. Okay, this is a problem area. And let's look at the statistics uses also. And here we can see that some of these tables, like okay, modification based on modification counter, this is very high number of modification was done this many times, and outdated by days is more than 531 days. So it's something like I never updated this statistics on this database. So that could also lead to a slowness of server performance basically. And now these are the main area. Now let us talk about look into the next thing. Next thing is like, if you want to develop your own monitoring solution, you can simply run these queries using a agent job in your SQL server, and on a particular interval of time, you can supply, where condition, wherever the last timestamp was pulled the data on any data that is available from last timestamp, get the next data and push it in your own basically a table. So thereby you will be continuously monitoring, and it will get easy to understand later on that where is the bottleneck basically. And let's go to another next slide. Now coming to the solutioning part, what could be the solution? So briefly, let us understand that, okay, any query that is taking huge amount of IO uses, we can review using this extended event. We have a physical read and logical read information related here. Okay, we can see that highest CPU was consumed and what is the physical read, logical read, writes, read count, row count, etc. So we understand from this that this query is taking high amount, I mean, returning very high data to the application that should not be useful, I guess. Okay. but we can see the query itself. Okay, why the application would need 10, I think 10 hundred thousands of data. It can never be a situation. It can be in a job, or it should be in a maintenance related query. But if the application is retrieving so many records and not displaying in a application, is useless basically. So this is just a small example, but such scenario can resonate in your cases also. So we can understand, okay, that there is a problem with the data set, and we should limit it by applying proper where condition and uh, joins basically. So similarly, we should also take a look at the execution plan of the query and take a look at the large index scan, table scan, or most common operator that is causing the slowness. We can simply mouse over to the operators and take a look at the which particular area the SQL is the query is taking high resources. We should also consider transaction be very small to avoid blocking and deadlocking. If we have large number of database files, we should consider partitioning of that, because it will reduce your maintenance job basically. Okay, maintenance job time, and thereby it can improve the performance that in those area also. We should always it is recommended use premium disk like SSD, or whatever very high powerful disk are there. And now, at the level, okay, hardware level, we can use the powerful server. If we think that there are high load coming continuously onto the server, we should think of applying powerful servers. And the next step could be we should offload database to the another server. So in order to balance the load on one particular server, if we have multiple number of database on same server and multiple application is hitting to all of them, we should consider offloading it to another server. And if the environment is a read on secondary replica concept also, which can transfer the secondary, I mean, read operations or read request to secondary replica, basically. So thereby, this can also automatically take care of your load balancing thing on your database side. Now let's go to the next slide. Now, now we have talked about all this doing it manually, how we can do it. Okay. Now there is also a free tool called SQL Planner, which can automatically do all this for you. Okay. Now to open this, let me log into the SQL Planner, and we can see that, okay, this is basically a monitoring tool, and we should look at the basically what is the server resource usage. So what I'll do is simply I'll go to analyze server performance health and choose the server and click on show report. It can tell me quickly in a graphical format that what was the CPU consumption by SQL and by other process and total consumption. Similarly, we can see it for memory wise also. And at this time, we see that, okay, the SQL memory has spiked up. Another thing like batch request and buffer cache hit ratio is also available. But main point we would like to focus here is to look at the expensive queries. We can see it in overall, okay, that this master has lot of master database has a lot of requests coming in. And since I did it through all by my manually through SSMS, I see that a lot of them are from this. But here at the below, we can see that, okay, some expensive query are, more than 10-second or 30-second. This is where we should look into and is of interesting. to understand what happened exactly. Now, we saw in the extended event that some query we had run to create a slowness scenario. So the same thing that we were seeing it in SSMS output is available here in a nice GUI format. And we can see, okay, CPU time it was 10 seconds for this particular request. Okay, so we can understand at this time today at 2 o'clock around, if the CPU is high, then this query could be a problem. Okay, we can also mouse over and see that, okay, 2 o'clock, 3 minute, okay, the CPU went up little bit, and we can apply all those conditions here and see it. Now coming to that deadlock report also, we can see that, okay, all those, we ran a deadlock environment in POC databases. We can see complete information here that, this is the query that was victim, or which one is the successful session. We can see those details here, and table names, the database name, the application name, everything is available in detail basically. Under blocking, we see there is nothing. Okay, these are not of interest at this moment, but let's look at those things which we did manually, and how it appears in this free tool. And let's look at the latency part. The latency part is here. If I click on this and choose our main server where there was a problem. Okay, we see that, okay, this database shows that TempDB has very high latency in a graph, and we also see in a tabular format that there was a problem. Okay, this is as on this, and this is a graphical format. So this talks about latency, check connection count and KPI. Okay, now let's look at the, how much uh, what was the basically number of connections, how many queries was executing per second, all those KPI that if we want to look at the performance related information that is available here. So we can simply look at those graph here, and this tells us basically what was the performance at that particular time. Now, if we want to see the fragmentation related information, we can simply see that also here. And I'll choose, I'm interested in this database, more than 30% of fragmentation. List me those tables basically. Okay. Now I see that, okay, this table which has highest number of records is highly fragmented, and we can defragment instantly or schedule it on in a job also. So all those informations are available for us to analyze. And yeah, you can download it from this website, mssqlplanner.com, the free version. And what this tool can do is also, deep monitoring and deep analytical reports. It can do alerting also. You can see, analyze your agent job. You can analyze monitoring dashboard, and it also provide you the backup solution and auditing solution as well. And yeah, this is all that I had to share. Now, um, yeah, if there is another any questions, I'll be glad to answer that.